Hello, in this video we are going to learn how to write the VSEPR structure for beryllium dihydride. First thing we need to do is do a Lewis dot structure. We have beryllium and we have hydrogen. Beryllium has 2 valence electrons. Hydrogen has 1 valence electron. This means that in our total bank we get 2 electrons from our 1 beryllium plus 2 electrons from our 2 hydrogens for a total of 4 electrons. Now, normally we would want to place the least electronegative atom in the center, but we can't do that in this case because hydrogen has to be terminal, so we need to have Be in the center and hydrogen on the outside. We had 4 electrons and we just burned all of them, just forming those 2 bonds, so we have 0 electrons left in our bank now. Now if we look at the bond dipoles here, now in most cases we put the more electronegative atom on the outside and the bond dipole comes out from the center. In this case we were forced to put the more electronegative atom on in the center, so our bond dipoles are actually going to point inwards like that. This is a special case because we do not have a full valence for Be. This is what we call an electron deficient species. And that's going to happen a lot with the Bs. Okay, so that's boron and beryllium. When we see those, we should think this may be an electron deficient sort of situation. Now what we need to do is get our steric number. The steric number is going to be the number of lone pairs on the central atom plus the number of atoms it's attached to. There's no lone pairs, just these atoms, so our steric number is 2. And the number of lone pairs on the central atom is going to be 0. We come down to this guy here. We need to find the steric number of 2. We see we got the case where we have a lone pair of 0 and that we're predicting a linear structure. So this is a case where our Lewis dot structure pretty well predicted our VSEPR structure. It really is just a flat linear structure, and we know that our electron geometry is going to be linear, and because we have no lone pairs on that central atom, our molecular geometry is also going to be linear.